So I'm going to show you a shortcut for KSP and molar solubility. Now this shortcut only works when you don't have a common ion. In the next series of lessons, you're going to learn about common ions. And so it's not going to work there. You do have to write the ice chart. But what this shortcut does is it helps you bypass the ice chart and bypass a lot of the extra steps in it. And so the reason that this works is that when you make combinations of salts that are made from positives and negatives, there's only so many combinations you can get. So you can see right here, I've got a positive copper, it's just +1, and a negative chlorine. So that's one way that you can end up with two ions. Notice there's no subscript, no subscript. That's one way, and you can see over here, this should all be making sense the way I've got this written. This is just copper plus, we've got chlorine minus. It just breaks into an ion and an ion. And then over here, here's the KSP written out for that one because it's just each ion times itself. I'm going to jump to the next one, and then I'm going to show you how they all come up with the same KSP. So in this case, I have a sulfur. It's a -2, but it's paired with something that has a +2. So again, notice no subscript, and it's a 1-to-1 ratio. And so that's why when I write the two products, you can see there's just one of each of those, and I have that same kind of a KSP expression where it's just something times something else. And then finally, and there aren't as many of these, but if I have a +3 with a -3, again, no subscript. This isn't a subscript for the PO4. That's just part of the group PO4. So this is like saying this whole thing has an understood 1 because the PO4 stays stuck together as a group. So because of that, you can see that on the right-hand side, it's 1-to-1. And then I've got that KSP written out, and that the KSP is just each ion times itself. So the way you get one KSP that represents all of these situations is, remember the left-hand side doesn't matter. Initially we have 0, we gain X, there's no coefficient, right? So that's X and X. So when I plug that into my KSP, I get X times X, which is that my KSP is X squared. Let me do it for the next one. So again, this is 0 and 0, X, X. And so now when I plug it in, I get X times X, which is X squared. And then for the last one, again, 0, 0, X, X. And then when I plug them in, I get X times X, which is X squared. So you can see in every situation where I break into two ions, again, it doesn't matter the charge as long as the charges are the same quantity. They have to be opposite for them to be a salt. But as long as they're the same quantity, I'm only breaking into two things. Every single time my KSP is X squared. And also note, this is another reminder, my exponent matches how many things I've broken into. One scenario, X squared is when you break into two ions. Let's see what happens when you break into three ions. All right, so for these three ions right in here, the only way that I can ever end up with three ions, I can't end up with three ions when I've got like a positive 3 somewhere in there, because you're going to need lots of something to balance out the positive 3. The only way you can have 3 ions is if you have either a +2 paired with a -1 or a -2 paired with a +1. Those are like the only ways. You can play with it and try and figure it out on your own. So you can see though, because I now have a subscript, I have a coefficient that falls over there. And again, subscript coefficient. Notice that I have a total of 1, 2, 3 ions. 1, 2, 3 ions. So in both these cases, I have 3 ions coming apart. So let's see what happens with the K chart in that situation. So again, it's 0, 0. This is X. Don't forget that becomes 2X. And then when I fill it in, my BA goes in as X. This whole quantity goes in as 2X squared. Don't forget that the 2 is squared. So that becomes 4X squared is what that becomes times the X. So 4X cubed. Let me show you it happening in the other one. So that's 0, 0, 2X, X, 2X, X. So again, 2X squared, or squared times X. So that whole quantity there becomes 4X squared. But then times X makes it 4X cubed. And again, like before, notice that the exponent is the number of ions that I've broken into. So anytime you have 3 ions, it's going to be 4X cubed. And then we have the last two scenarios, and these are much less common. I would definitely say this is more common than this, but in both cases, there just aren't that many ions like this. Salts like this that are insoluble and that break into 4 in the way that I've got shown. So I just have one example of each of them. Notice that because of the 3, that's why I've got the 3 in front. That's also why that exponent is 3. And then like in this case, it's basically an understood 1. So I have a total of 4 ions. So when I fill this one in, this gives me x, and that's 3x, so x, 3x. So my KSP becomes x times 3x cubed. Remember, 3 cubed is 3 times 3 is 9 times 3 is 27. So 27, and this is x cubed times x to the 4th. Notice 4, 4. That's also just a nice check for yourself too. Then finally, I have 5 ions, and so 0, 0, 2x, 3x. And when I fill them in, I get 2x squared times 3x cubed. And so basically what I'm saying is I have 4x squared times 27x cubed. What that turns out to be is 108x to the 5th. Again, that's a much rarer scenario. If I was going to memorize 3 of them, it would be for the 2, 3, and 4 ions. Maybe not this one as much, but that's the other scenario. So again, the great thing on this is if you know how many ions it breaks into, if you know the molar solubility, boom, you can solve for the KSP. If you know the KSP, boom, you can rearrange and take the 5th root after you divide the KSP by 108, and you can get the molar solubility. Final word of caution, I said this at the beginning, make sure that you don't try to use this with common ions, which is in the next section. You really do need to use the ice chart for the common ions.